Toplantım var yine. Şöyle hızlıca alayım mı sizi?
Good afternoon, everybody. You're all very welcome to our Introduction to AI session. We'll be starting at 2 o'clock. And there's, I think, a few more to join us, so we'll wait till they join. Hi, Agnes, how are you? Can you hear me okay?
Let's wait 5 minutes more. Hi, everybody, everyone.
Just checking. Can you hear me okay, Agnes?
Hello, Aoife.
Hey Dara, how are you?
I'm not too bad. And yourself?
Not too bad at all. How's the weather up in Donegal today? Did you get washed away at the weekend?
There was a lot of flooding.
Sorry.
It was a stormy weekend anyway.
Yeah.
Nothing we're not used to.
Oh, I know. Although Killybegs seemed to
It got
got a bit of a battering.
it did indeed.
I read something like it was big flood in Killybegs, isn't it, Dara?
Yeah.
Oh, like a tree fall down or something. Mario was commenting here in the office.
It was quite severe.
Yeah, I think was it a tree fell down and blocked the river?
Blocked the bridge and it just came up and over. By all
I
accounts.
don't know if it's my problem, but I cannot hear nobody of you. I don't know why. Oh, now yes. Okay. Okay.
Okay. Always happens. When you say that you can hear anywhere, something happens.
Yeah, it's always like this.
Magic.
It's like the machine can hear me. I say, okay. Okay, let's wait a couple of minutes more just to be sure that everybody is online. Okay, I think that we can start. So I will share my desktop right now. Okay. So everybody of you can see, right? I open the microphone because I cannot see it, just to be sure.
Yes, we can see.
Okay, thank you. So welcome everybody to the second session of the second training of SeaBridge, the project SeaBridge. And today we're going to have a training that the main topic is the supporting of the digital transition of small medium enterprises. And first, I will do a really short presentation about the project and about the trainer. And we have a small break. The training will be divided in two parts with a small break, about 10 minutes, no more. So the Sea Bridge project is a project that is financed by the COSME program from the European Commission, and its main topic, its main objective is to help small medium enterprises to be aware of their environmental impact of their emissions, and help them to have a greener and more digital production. This project is the partners are from seven. They are seven. Two from Ireland, one from Slovenia, two from Spain. The main one, the coordinator, that is from Turkey, that is IMIB, and then one from Italy, that is CEPES, and I'm part of CEPES. Then a small presentation about the trainer of today, Aoife Darcy. She is a CEO and co-founder of Chrysalis. She has more than 20 years of experience in the areas of data science, machine learning, and artificial intelligence. She founded in 2009 the Chrysalis, that is his objective is to help organization to build world-class data science, machine learning, and AI teams and processes. She is also a writer and a co-author of the textbook Fundamentals of Machine Learning for predictive data analytics, algorithms, working examples, and case studies. So I won't take more time to this training, and I will leave the word to Aoife.
Thank you, Agnes. Thank you so much for the introduction.
Thank
and
you.
thank you so much for inviting me here today to talk to the group. I suppose working, I'm just going to share my screen now. I suppose working with an SME ourselves, so we have less than 10 employees here in Chrysalis. I know the challenges that face small and medium enterprises in all kinds of areas. And lots of times it's resources, it's finding the time, and particularly when we talk about the whole area of AI, and it's such a new area, and sometimes for smaller organizations it's finding the time to invest in just figuring out what these technologies are, what they can do for your organization. And it could almost seem like just this, massive big mountain that you almost don't want to start climbing. So I suppose there's a few things we want to talk about today, just in terms of thinking about that whole space of AI, because it's huge, okay? And we could, probably sit here for a week and uncover lots of different things about it. But I suppose what we want to do is, first of all, talk a little bit about what is AI. Then I want to think about, in that kind of in that SME kind of sector, what are the things that you can kind of be looking to doing? Where are the efficiencies and the opportunities that lie within AI within your organizations? Some of these may not be new, and some of them may be some of the newer AI technologies, but thinking about where those opportunities lie. Then we'll think about what the pitfalls are, then building some trustworthy AI, and then Q&A. And as Agnes said, in middle there, we'll find some time for a break. So I suppose to get going, the first thing we're going to think about is, what is AI? Okay, and I'm just going to ask people in the group to tell me a little bit around, can you think of any interactions you've had with artificial intelligence today? So if you wouldn't mind just using the chat to let me know. So have you used any AI tools? Have you integrated with a tool that is based with the AI? Sometimes people are interacting with AI and not even knowing about it. But just if people could just, so my accent, yeah, absolutely, ChatGTP. I myself have also done a little bit of ChatGTPing this morning, really useful. Google Directions, thanks Dara, absolutely. Good old Google Maps. That kind of idea of optimization, and we're going to talk about that a little bit more. Anybody else? Anybody have any other interactions with AI? Perplexity. That's from David. Now that's a tool I'm not familiar with. But I'll take your word for it. David, so Copilot from Jose, absolutely. And we're going to talk a little bit about Copilot and those generation tools, because I think particularly for small organizations, there's definitely efficiencies that can be gathered. Any other ones? I think that's a pretty good list. The other things that people might like, if you have any of the tools in your household, cider from Fatima, again, that's one I haven't heard of. So that I'm going to have to be doing a bit of Googling later. Anybody who has any tools in their house that they talk to, so like the Alexas and the Siris of the world. I have a daughter who loves going to her grandmother's because she gets to ask Google to play music for her. She loves a bit of Hey Google. Those tools are all using AI. Anybody who has any sort of robotics at home, so anybody has any fancy, kind of robotic hoovers or anything like that, there's little bits of machine learning and AI in there. Yeah, so there's probably lots of areas that we can kind of go, oh, actually AI. So this sense that AI is new or it's just arrived, it's actually been here for quite a long time at this stage. But I suppose some of the tools are newer and some of the opportunities are newer because it's more easily accessible to us. So just in terms of what is AI, because I think it's really important before we start talking about something or talk about the opportunities of something, we define what it is. So first of all, AI has been around since the 1950s as a term. So it was first coined in an invitation to a summer school by a professor at the time called John McCarthy. And John invited himself and 9 colleagues to a summer school in Dartmouth. And he wanted it to be a 10-man study of artificial intelligence to be carried out during the summer of 1956. So he sent this invitation in 1955. And I suppose that idea, if you think about when this time was, so this is around the time where I suppose mainframe computers were becoming into existence. I mean, they took over the size of a room and they were huge. But that idea of having computer power and computer processing, if we think it was the time around Alan Turing was coming up with the Turing machine. So this concept of machines doing tasks for us was kind of coming into vogue. And I suppose they coined that for that term artificial intelligence. Now, it's one of the terms that people often give out about the term artificial intelligence. So using that word intelligence kind of brings up a lot of I suppose people like, can a machine be intelligent? So for today, we're going to park some of those kind of philosophical type questions. And we're going to kind of look at a definition of AI. We'll talk about this in a little while, but we have the AI Act. So the AI Act is coming into being, and it's something that anybody working within the EU is going to have to think about kind of being compliant with. And I suppose what I like is, in order to produce a regulation around something, they had to define it. So this is a pretty good definition to use. And if we break it down, so artificial intelligence systems, or AI systems, mean software. So first and foremost, AI, they're not robots, they're not people, they are software systems, okay? That is developed with one or more of the techniques approaches in Annex A. So this is Annex A. And really important, for a set of human defined objectives. Okay, so this sense, and people sometimes awful talk about narrow and wide AI. For the moment, wide AI is having machines that can kind of live and operate like humans. Okay, which isn't really how AI works. What we call about narrow AI is where it's an artificial intelligence tool or a piece of software that has a very specific job in the world. Like if we think about, Google Maps, we use it to get from A to B. Okay, that's its goal in life. So I suppose it's really, really important that we as humans define the purpose of our AI tools, and we build those tools for a specific purpose. They generate outputs. Okay, so it's a software program that we determine what the objective is that generates some output. Now, that output can be content. So I think whether they're mentioned mentioned using Copilot. So was probably creating some sort of text. Okay, so we can create content. We can create predictions, recommendations, and decisions influencing the environments that they interact with. Okay, so I suppose it's really important that we kind of hold fast to this definition of AI instead of trying to seep into this sense of intelligent systems. Well, particularly at the moment, and particularly if we want to think about what are the useful things we can start doing with AI. Okay, so there are computer programs that for a human set of objectives, so what we want to do, it can generate things for us. Okay, and the types of techniques that they use are things like machine learning, logic and knowledge-based systems, and statistical approaches. Okay, now where the different techniques are going to become important, and particularly going down, kind of looking at the AI Act when people have to start kind of implementing kind of processes and making sure they are AI Act compliant. You're going to need to kind of know and understand where AI is being used in your organization, and a good way to start is where these techniques are being used. Okay, a useful definition though that we use is that AI can be defined as the science and engineering of making intelligent computer programs capable of performing tasks that require the subtleties of perception, interpretation, judgment, and generalization that we've associated with human intelligence. So it tends to be, these are computer programs that do tasks that we would generally associate with a human. So things like being able to give directions. So, I remember for years before the advent of Google Maps, if ever I wanted to go anywhere, like I'd ring my dad. I'd be like, Dad, I'm trying to get to Cork. What's the best way? And you would get the intel, he'd be like, oh, you're better now. Don't go through that town, go through this town and take that road. So that sense of, giving directions, or even like creating a document. Like if we want to create a proposal for something, we would write it. Okay, where now we can start to ask computers to help us with those tasks. So that sense that the tasks that we're talking about are generally a little bit complex. We're going beyond, I suppose, pre-AI when we think about computer programs. Computer programs are generally kind of rule-based programs. So if they made a decision about something, it was because we had given it a set of predefined rules. Okay, so for instance, in Ireland, if you're applying for a pension, you have to be over the age of 66. So in the welfare system, there's a rule that says, is this person over 66? And you would have to, build that rule into that system in order for the computer to make a decision. So I suppose before AI, most decisions that computer made were kind of hard coded. Now we're allowing the tools to kind of just be a bit more sophisticated. Okay. So any questions about that definition before we go on? So we have a relatively small group. So I'm happy to take a few questions as we go along if anybody has any. You can just raise your hand if you want, or pop a question in the chat. And please feel free, if you do have questions as we go along, just pop them in the chat or raise your hand. As I said, we have a relatively small group. so it's not a problem. So I don't see any questions coming through there. So cool, I'll keep going. So having defined what AI is, right? So we have a definition of what it is. So this idea of, I suppose, computer programs that act in a human-like way or produce output that historically we would have gotten from humans. So now what I want to think about is, well, what are the opportunities? What are the ways that we can use AI, and particularly in the areas that you're looking at? So when we think about uses of AI, and some of you may have seen presentations by us before, you'll get used to this wheel. And basically what we like to think when we are thinking about the ways that you can generate or use AI, there's so many different ways that it can be difficult to get a handle on it. So what we think about is, well, what are the different types of decisions or output that we can generate using AI? And if we can classify those and break them down, we can look at examples under those classifications. So this is what we call our AI wheel. And these are just different ways that we can categorize how we can use AI. Okay, and what we're going to do is we're going to, for the next kind of half an hour, 35 minutes, just look at some of these ways that we can use AI. Excuse me, I'm just going to take a drink. And think about how we can kind of break down the different uses. Now, I always like to say, when we look at the first kind of half of this, so labeling around optimization, there are probably some of you who've worked in roles, particularly technical roles. If you've worked in a technical area last 20, 30 years, you've probably done some of these tasks without necessarily using AI. Okay. I suppose, optimization is one. Optimization isn't a new topic, but what has changed is that we are starting to use more and more AI systems in these areas. So it's not necessarily that, kind of these are new topics, but sometimes it's our approach to how we're solving them that is using more and more AI. Okay, so first of all, we'll talk about two more definitions. So we've done our AI definition, so that hasn't changed. Okay. One key area that you will come across, and this is just, I suppose, that kind of demystification, is the area of machine learning. So the predominant way of doing AI at the moment, there's lots of different ways, but it's mainly machine learning. And machine learning is a set of techniques where we take knowledge generally in data and observations and interactions. So we take information that we have or data that we have, and we apply a set of algorithms to that data in order to learn and extract insights from that data, look at patterns within that data that allow us to do these things. So create labels, predictions, recommendations, and generate content. Okay. So when we talk about, I suppose, a lot of AI systems, we're really talking, so if we lift underneath the hood, they're really machine learning. And one key thing to think about this, because we're going to come back when we start looking at some of, I suppose, the pitfalls and the risks of AI, is a lot of the tools are dependent on data. Okay. And anybody who's worked in any sort of kind of analysis or analytics roles will know that unless you've good quality data, you can't create good quality systems. And this is no different from machine learning. Okay. So a lot of the pitfalls and a lot of the issues that come around when we start thinking about, where could this possibly go wrong, tends to be about the data that we use. So we'll talk a little bit around that. But machine learning is just our ability to be able to extract information and insights from data. Okay. Now within machine learning, there's a subfield of machine learning called deep learning. Now the only thing you have to know about deep learning came into existence now about 10 years ago. We started to use it a lot more. And the only difference with deep learning is it's a bit more complicated. So the maths and things that are going on in the background are a little bit more complicated. But the big difference is the type of data that we can use. So prior to deep learning existing, so when I was working building machine learning applications in like the early 2000s, we primarily used data that came from structured tables. So like a database. So you can think of an Excel table, right? It was that sort of data was the data that we used. And if you asked me to build a prediction model or a recommender, it was that sort of data that we used. What happened around 10 years ago was because basically computer power allowed us, we started to be able to apply the same types of techniques and algorithms to different types of data. So to images, to text, to audio. So all of a sudden I could look at a picture and determine whether or not there was a cat in the picture. Or I can look at a satellite image and determine the proportion of tree coverage there is. So all of a sudden, our ability to be able to analyze that type of data just grew, and mainly because of computer power. All right. So all deep learning is, it's still machine learning. We are still looking for trends in data. We're still trying to create labels and content and prediction. So all of that stays the same. The only thing that's different is really that type of data. And because images and text and audio, they're just more complex, we just needed more sophisticated computers basically to be able to do it. And we have that now. So we have all kinds of fun that we can have. So what we're going to talk about now are the different applications that we can use in AI. So what we're going to do here is we're going to think about, so what are the areas that people are using this idea of labeling, okay? Again, labeling isn't a new kind of phenomenon. Kind of labeling tools have existed. So I don't know if people are used to their spam filter in their email. So your spam filter is essentially an AI labeling tool. So what it does is it labels as an email comes into your inbox, it puts a label onto it as to whether it's spam. And if it's spam, it goes into your spam folder. And if it's not spam, it goes into your inbox. Okay. And that's a labeling kind of task. So it looks at the current version of an email and it labels it something. Okay. Now, if we look at kind of more sophisticated type of labeling tools, one thing that you might be able to do is take a picture of something. Like here, we might be able to take like aerial photographs of pylons. I know this is something that our electricity and supply board here in Ireland are looking at, and to see if they can label, they can find faulty items here. So where you can take a picture of something, so it might be, you know, something within a manufacturing plant. It might be here. It might be something external. So it might be, you know, some sort of asset, or you know, we've worked with people who've worked maintaining oil rigs. So anywhere where you have kind of imagery of something, you want to assess that thing and see whether or not label as something being faulty or not faulty. Then that uses AI. Okay. The second example is a nice example that I like, because I suppose it's not, I suppose, a traditional use of labeling, or not something that people would say. So generally when people talk about labeling, they, you know, like spam filters, or there's lots of examples in healthcare where you look at an image, an x-ray of somebody, and determine whether or not, you know, they're ill or not. This is an example where the UK government took a set of documents and determined they wanted to release these documents into the public. So they analysed the documentation to determine whether certain text should be redacted. So there were parts of documents that they didn't want in the public domain, but they wanted to be able to submit most of them. So this idea of being able to analyse a kind of a piece of text and being able to label it, elements of that text, as X or Y. So in this case, it was this information is sensitive and should be redacted, and this information is not. But you could think about using that in other kind of ways. So if you're looking down through like a regulatory document and saying like, this is a piece of regulation that adheres to us and this piece isn't. Okay, so you may look at kind of different ways that you can use these types of tools where you're looking at text and identifying different types of text, and something that might be of interest to you as an organization or something might not. Okay, so anything where you're looking at an image, a piece of text, or even some tabular data and labeling something as being X or Y, then that's essentially something that we refer to as AI. It's probably using AI to do that. Okay. So when we move on from labeling, we can then go and look at prediction. Okay. And this is probably an area, I suppose, for kind of smaller organizations where there's probably some nice applications out there where you can look at things like energy usage and energy consumption within your building, and to see if you can predict how much energy you're likely to use, and then do things like predict. So things like demand forecasting. So if you can think, well, how much energy are we likely to use? Is there ways that we can, if you have peaks within energy, is there ways within your organization that you can kind of reduce that energy consumption? So if you can predict it, then you can look at ways to maybe reduce it before you've used it. So these are the types of things. So forecasting, prediction. What we're doing here is we're looking into the future and saying what's likely to happen. So how much energy are we likely to use? The other area where sometimes if you're managing, again, kind of different assets, so machines, predicting if something is likely. So in this example, we looked at an image of something and said, is there something faulty or not in this image, right? The other area, that you can look at here is the idea of maintenance schedules. So can you predict if something is going to have a fault, so therefore you fix it before it goes faulty? So that people talk about this as predictive maintenance. And what you can do is you can really reduce your costs if you can manage your maintenance better. So if you have to bring a maintenance team in, being able to plan that out and make sure kind of when they're on site or when they're with you that you're utilizing their time as much as possible, as opposed to waiting for the thing to break, then bringing the maintenance team on, having big charge out fees, things like that. So the things, if you can better predict those sorts of issues before they happen, you can manage those maintenance schedules better. And things like supply fluctuations. So if, for instance, you are looking at your energy and you want more of your energy to come from green sources, so particularly looking at, in Ireland, I have a cousin who works in the department who are looking to basically make Ireland the wind energy hub of Europe, that we have so much wind. And for our friends in Ernacht who are Donegal based, they knew all about the wind this weekend because we had a big storm. So that idea that if you're generating green energy, can you kind of predict supply fluctuations, so know when, if you're having more green energy produced, is that when you ramp up the use of energy because people are using more green energy? And then where you're going to have lulls in the production of green energy, is that when you try and get kind of different areas to kind of use less energy? So to make sure when people are utilizing energy or having those high utilization periods, if you can predict those fluctuations, then you can manage the system more, and particularly manage people optimizing to using more green energy. So all that area of forecasting and prediction is a big area for AI. And again, not always that new. I've been building prediction models for the last 20 years. But as I say, sometimes now some of the data that we're using and the volume of the data that we're using is much more than what we were doing 20 years ago. Then there's recommenders. Now, traditionally, when we think about recommenders, we think about things like Netflix and Amazon, or going onto some retail site. So we're all going to be getting ads now from Black Friday sales of people recommending things for us to buy or programs to watch, things like that. But I suppose when we look at ways that I suppose we can use kind of recommenders, one of the areas that we can look at is kind of making recommendations to, maybe if you're, managing energy consumption with the building, can you make recommendations on how people can reduce using energy in that building? This is actually a picture of Electric Ireland, our electric company here, who are, showing people kind of on an app. You can, tell people how they can reduce their energy consumption and then reduce their energy bills. So that idea, I suppose, as I say, traditionally recommenders were used very much in kind of that retail space. But there's probably lots of things that we can do either to individuals, so to our customers, to recommend to them to how to optimize and reduce their use, or even then within an organization, within a building, the people who are managing the assets and the building, is there ways that they can manage the building better to reduce consumption. So control is the next area, and this is probably for kind of any industry. I suppose the obvious one is self-driving cars, and I suppose with the new administration coming in the US, and particularly I suppose with Elon Musk being evolved heavily in that administration, you can see definitely from a US perspective the use of self-driving cars being used kind of much more and becoming more mainstream than possibly they might have been. And I suppose self-driving cars is one area. It's kind of interesting. But one of the areas that I suppose where efficiencies can be gathered is in kind of manufacturing areas where you can automate kind of processes. And I know there are, kind of certain manufacturing sites that are kind of automating, kind of almost going to fully automated kind of manufacturing. And this is an example, and you may not be able to see it well on the screen, but these are actually bottles of Corona beer. And this is an example from the Corona beer factory in Mexico. And these look like these kind of big kind of pallet moving kind of devices. Essentially, these are automated forklifts. Okay. And what the organization were able to do was they basically fully automated. So they invested in these kind of automated forklifts, and they're able to kind of reduce their staff. So they had to manage their factory. They used to have, I think, 80 manually used forklifts. Now they have, I think, 50 of these electronic forklifts. So they've been able to kind of automate that process, but also reduce the amount of energy that's required for that process in kind of using these automated and having everything more scheduled and a little bit more organized. So again, these are just areas that we are seeing, I suppose, AI being used within kind of different industries, and definitely kind of automated vehicles and automated processes. I think we're going to see more and more. The other area where I've seen this used is in big ports, kind of automating, so loading and unloading cargo from ships, that sort of area as well. Lots of automation happening there. Okay. Another area where we are seeing, I suppose, lots of, I suppose, good examples of AI and really useful examples of AI is optimization. So we've already talked about that idea of Google Maps. Okay, for me, Google Maps is a really good example of automation. And when we think about automation, or sorry, optimization, what are we talking about? So we generally think about talking about, kind of completing some task. Okay, so in Google Maps, it's the task of getting from A to B. Okay, and we tend to want to optimize that to some kind of KPI. And generally for Google Maps, it's about getting there as fast as we can. right? So getting from A to B in the quickest time possible. So therefore, we're trying to minimize. What we're trying to optimize there is the amount of time. So we're trying to minimize the amount of time. But then a lot of times with optimization tools, we tend to put in constraints, okay? And a constraint might be for Google Maps. You might say, well, what if I don't want to go through a toll? Or what if I only want to use motorways? Or what if, so we can start to adjust our route or the answer to our question, depending on a set of criteria. So we're saying, I want to go from A to B as fast as possible, but don't bring me through any tolls. I don't want to pay any tolls. Or you may want to say, well, I want to minimize my time, but I also want to minimize, more importantly, the amount of fuel I consume. Okay. And when we're talking about optimization, essentially you're generally asking a computer to do something for you, like here, give me a route, and then you're saying it and minimize something or maximize something, right? And these types of tools are built into all kinds of things. So things like supply chain optimization. So if you are, right? So if you are working anywhere where you are, bringing in raw goods, you're doing something with those goods and then you're exporting them. So in any industry like that, there's lots of optimization that you can do just to make sure that you're getting the right materials when you need them in the right amounts, not overstocking on certain materials, so you're not storing things that you don't need, in order to produce or manufacture what it is you're manufacturing, and then to be able to distribute that and get it out to your customers. And what you want to make sure is that you understand what your customers are need. And sometimes this starts with being able to forecast what your customer wants, and that kind of idea, demand forecasting, and then working backwards to make sure that at each point in the chain of going from getting your raw material to your good to your customer, that there's lots of little ways that you can use AI along that process in order to optimize it, in order to make sure that you are delivering your end product to your customer, but probably reducing costs, maybe reducing time, possibly reducing emissions in that process. So once we start getting into that kind of area of kind of supply chain optimization, we can start building in that sense of not only do I want to optimize over time and cost, but I can also look at things like emissions and look at ways that I can do things maybe quicker and using kind of digital tools, but still get a positive outcome from our customers. So we still want to have happy customers at the end of it. And then another area, if you're in Ireland, we're very fond of our agricultural sector and we're really fond of cows. Farmers in Ireland love their cows, but more importantly, they love their grass. So I know there's lots of research going on in Ireland in the area of farming, in not only trying to make, I suppose, our farms more efficient in terms of, kind of output, but also making them more sustainable. So it's getting that balance between optimizing output, so getting the most yields you can get, but also making sure you can do it with the minimal amount of impact on the environment. So it's probably another really nice example of kind of optimization in that space. Now, up until this point, right, a lot of those tools and techniques that we've talked about are really dependent on kind of tools that have been around for quite a long time. And I suppose with the advent of AI, we're just getting better and quicker and faster at them. Okay. So it's not that some of these are necessarily new, but certainly the amount of heavy lifting now done by AI is much greater. So the things that we can do are just more impressive. Okay. But the next few areas that I'm going to look at, translation, generation, and interaction, are definitely areas that either didn't exist at all 10 years ago, or have just become so much better. Okay. And when we think about AI and translation and text generation, there's an area of expertise that people talk about is this area of natural language processing. And natural language processing is just our ability to be able to, I suppose, digitally process text and language and speech. Okay. Now, again, it's not a new area. Okay. But what probably is new is when we mix all those nice natural language processing techniques that we've been using and utilizing for the last 20, 30 years, when we mix those, particularly with deep learning, we can build a really nice set of AI tools that allow us to generate text, to generate voice, to generate audio, that allow us to generate very realistic kind of text and audio. So these are kind of it's the mix of these two things. And you can have a read through this. I'll make sure that the slides are sent out. But these are kind of the areas of NLP, I suppose the traditional areas that we would work with in NLP. And when you mix this with deep learning, you get some really nice sophisticated tools. And these are some examples of translation tools. So the obvious one is just being able to translate text from one language to another. And these tools are getting so much better. Okay, so again, 10, 15 years ago, automated translation was pretty dodgy. Right? Anybody who's worked in this area, will know. And there's always really good examples of things just being translated really badly by computers. But AI, and particularly deep learning, has moved this on massively to the point that now a lot of EU translations or translations on an EU level are actually automated. Okay, we can also translate other things, like this is translating colors, but generally in text, when we think about being able to translate documents into different languages, I mean, for small organizations, that's a really expensive thing to do. So if you want to move your business into a new market, if you want to, start selling your product, in Germany, but you're a French-based organization, like the translation of everything into German can just be, really expensive. Whereas now, actually, with a lot of these tools, it really reduces the cost of that it's not the block that it was. So, a good AI tool, and then having a subject matter expert just doubly checking things is probably, the way to go with this. And even in terms of, we're currently looking at generating some e-learning content, and somebody said, oh, you can just translate it and use an AI voice now really easily. And I'm like, are you sure? And they're like, no, honestly. So in the next probably 6 months, we're going to be testing that. So I'll keep you posted on that one. But that sense that, like, again, 5 or 6 years ago, we would have been, okay, we need to get somebody to do the translation in language. Then we need to get somebody, a speaker in that native language to do the voice recordings. Now, all of a sudden, there is a plausible option that can be automated. So from a cost perspective on our side, there's kind of huge benefit to that. Then there's generation, and this is probably the area that's got most focus recently. So generative AI, Copilot. I mean, this is just a funny image. It's the Pope in the puffer jacket, and completely fake, right? But so realistic, all right? And I think from an SME point of view, I think it's really, really important to be aware that these tools are out there and do have a massive use. I know we use them a lot. So where we use a lot of kind of Copilot. So this is Copilot. So here I've said, so this idea of drafting an outline of something. So here I said, can you create an initial outline of a request for quote for a new supplier on an energy tracking and optimization training system for a training company that owns an 8,000 square foot building in Dublin City Centre, Ireland. The building is 20 years old. All right. This is the type of thing that you can ask something like Copilot or ChatGPT, and it'll give you a first draft of something. Okay. And this idea of drafting things, it's actually quite good at it. It'll give you an initial draft. Now, then you'd have to go and fill it in and improve it. But that sense that you're not starting with a blank canvas. The other areas where these can be quite good is in summarizing a document. So if you've, written a document and you want to, let's say, create an abstract or let's say the executive summary, rather than having to write the executive summary from scratch, you might say, these are the 5 points I want in my executive summary. Can you create a first draft of this based on this document? So that idea of summarization is really useful. The other area where I've seen people use generation is things like, after a call like this, so you're on an online call, getting the notes transcripted, and then, having somebody, what are the action points, who are the action points attributed to, those types of things. So meeting summarizations, those types of things, again, really useful. Now, in all of those examples, and we're going to talk about the idea of trustworthy AI, you generally need somebody in the loop, so a human in the loop, to be checking that the output is correct. Because the one thing about these generation tools is they're good, but they're certainly not foolproof. And you've probably heard this idea of an hallucination. So an hallucination is just where a generator makes something up completely, that it's not real, it's not fact, okay? And they're very prone to this because their job is to simply generate text, okay? It's not to generate accurate text. So the human in the loop, us, people who are using this output, have to read it and make sure that the actual text itself makes sense. All right. And that, depending on the domain expertise, if it's something like legally speaking or very, we were working with a team of researchers last year and we took different papers and we summarized them. And we got the authors of the papers and their colleagues to review the summarization. And we used different summarization tools. So we were testing the difference between the different summarization tools, but also who could notice the hallucinations. And what was really interesting was that the people who had written the documents were able to point really quickly to where there were errors. Right? No, that's not right. That context isn't right. The people who hadn't written the documents found it much harder because the language that was used was really plausible. And this is where we have to be really careful with these tools. Okay, we have to make sure that if anything is being generated, that we have somebody with the right skill level who can check to make sure that what is being created makes sense. Okay, so these generation tools they're a little bit different than other tools. We can test output like an optimization. We can, our recommendations, our predictions, and our labels. We have really good testing mechanisms for those types of outputs. And a lot of times for generation, we almost need to be continually checking that things are right. Okay. And this is the challenge with them. And this is one area, my big note of caution is there's lots of usefulness here, lots of speeding up of certain things, but people need to be aware where the weak points are and make sure that we have the humans checking the output to make sure it's right. And then the last thing, and I'm just going to touch on this quickly and go the right way in my slides, and that's a definition for generative AI. These are the different kind of large language models that you might hear people talking about. And OpenAI uses Copilot. So just to be, when you're using Copilot, it's Microsoft basically underneath the hood is OpenAI. The last area just to look at is this idea of interaction. So this idea that you are talking to or using some sort of chatbot where you're interacting with a tool. And this was a nice example that I came across when I was looking into this of chatbots that have been generated by this company, Bravant. And this chatbot here was an AI assistant to help people kind of work with this organization to be more energy efficient. So, but it was an AI assisted tool. So you were talking to a machine and it was giving you recommendations based on what it had learned. But this is quite a nice example. And certainly in terms of, and this is where we'll talk after the break about kind of risk, where there's relatively low risk of somebody kind of doing something kind of, the risk of the outcome isn't, somebody isn't going to like harm themselves or be harmed. If it's kind of advice and you can give them references to where they can check the advice. And there's probably some nice kind of tools there that can be used in that sense, that people can interact with the tool in that very conversational type of way. And this is just a nice example that I came across in that idea of kind of chatbots for kind of people using kind of energy consumption in kind of a reduced way. So these are kind of tools, that sense of having a conversation with the tool, that have become much more realistic and much more useful, and definitely something that's worth investigating if you want to be able to. Basically, they're like, you can think of it as a fancy Google search tool. Again, you just need to make sure that people are aware, transparency, so that they're dealing with an AI assistant, and that they need to check, that if they make a decision based on what they're doing, that they need to just double check that the information they're getting is correct. So at this point, I think we might take a break. So I can put up a timer if we want, because when we come back, we're going to talk a little bit about the pitfalls of AI.
Yeah, I think that we can say that we see in 10 minutes, like at 4 and 5. 5 minutes, okay? So
I can
10
put up a
minutes.
10-minute timer.
Yeah, as you want.
So,
okay.
Yeah. So we will see everybody back in 10 minutes.
Yeah. Perfect.
Super. Thank you.
Thank you.
Thank you.
Hello, hello. Just to remind people while we're waiting people to come back, feel free to pop things in the chat as we're going along, and I will leave time at the end for some questions. We'll go through the next bit quite quickly. So hopefully if people have found this useful. Hello again, Jose. So I will turn off our timer.
Yes, we can wait like 1 minute more, just again to be sure that everyone is in. And in the meantime, if someone, as Aoife said, want to have some question or anything.
Hey, Florcia. Thanks for the thumbs up, Barbara. Great, we might get going again. So what we're going to talk about now are the pitfalls of AI. And what I just want to point out, and I'm not going to spend massive amounts of time on this because the one thing in all of the techniques that we've looked at, and one thing that I think that people forget is this idea that because a computer says so doesn't necessarily mean it's right or it's true. Okay? And in most instances, AI systems have a sense of accuracy built into them, or I would say a sense of kind of error. Okay? That at some point they will get things wrong. Now, generally, when we design our systems, we know what the error rate is likely to be. So our people will talk about accuracy. So people will more likely tell you, oh, my system has 98% accuracy. That means that it's wrong 2% of the time. So if that machine is making 100 decisions, it'll get 98 of them right, but it'll get 2 of them wrong. Okay. And this is what we really need to think about and be very aware of when we're engaging with AI systems, when we are building AI systems into our processes, that we're really aware of, well, how do they get them wrong? And then more importantly, and we're going to talk about this when we talk about the AI Act, which is the risks associated with that. Okay. So pitfalls of AI. So AI failures. This is one that I really like because it kind of highlights sometimes that the failures in AI are kind of nuanced. They're not always really obvious. And this is one that did a translation job where we translated, he's a nurse and she is a surgeon, to Turkish. Now, I don't know Turkish at all, but I do know that Turkish doesn't have gendered pronouns. So here, he and she, we disappear, like that sense of he or she disappears. So when we go and represent or translate this Turkish directly back to English, we will get he being a nurse up here now becomes she is a nurse, and she is a surgeon becomes he is a surgeon. Now you look at this and go, so let's go back and think about a few things that I said. So at the very beginning, I said a lot of the tools that are used in building AI are what we call machine learning tools. And they learn their trends and insights. So those machines would have learned how to do translation from historical data. And historically, girls tend to be nurses and boys or men tend to be doctors. So therefore, and this is what we call bias in our models. So our data is biased. Now, the world is biased. That's the way it is. Okay. But the language translator have basically picked up on that. So here we're essentially, when we translated from Turkish back to English, the machine had to decide the gender for the nurse and the surgeon, and it based it on gender norms. Okay, it's not unusual for females to be nurses and males to be surgeons. Okay, but you can see how just those biases that exist in our data get built into the systems that we build based on that data. Now, in this, nobody's really getting harmed. It's, you'll say, okay, it's, it's the way it is. But what we can see in other systems where the system gets it wrong, that there can actually be negative impacts on people. Okay. So here we can see this is actually taken from an image of somebody in New Zealand getting a passport. So you know the way you upload your passport image, and the tools now, and this it happens in Ireland, I'm sure it happens in most countries, there's a tool that tells you if the picture is a legitimate picture for a passport. Well, here, this person got blocked from proceeding because they were told that their eyes were closed by the AI. Now, this for me is, okay, the AI gets it wrong, but we have to expect that the AI gets it wrong. The problem with this system is it automated a process assuming that the AI gets it wrong or gets it right 100% of the time. And there was no kind of ability to put a human in the loop. So there was no button to press going, actually, no, I think my picture is okay. Can you have somebody check it? Okay. And this is where we need to be very careful. It's not just about assessing and knowing how many times our AI system gets something right or wrong. It's then making sure that when we develop systems around them, that we take that into consideration and we make sure that the system and the process around that's using our AI is built in such a way that allows you to mitigate this risk. So the problem here, there's no way that this person can mitigate the error. So they can't go, no, your AI is wrong, fix it, please. They just can't get their passport. Okay. And then this is just an example of Amazon. And this is the type of thing that you might try to do. Okay. You might go, oh, well, we hire lots of people. So if we could speed up the hiring process by maybe looking at CVs and determining if somebody should go to interview, that would be a really useful thing to do. But actually, Amazon tried this and they realized that their system was biased against women. And basically, when they started using the system, very few women got through to interview. And they kind of went, but we didn't use gender to build the model. So the data that we trained the model on, that we built the model on, didn't have gender in it. But sometimes the systems can pick up on these things. So the system here picked up on gender from things like female-only clubs, maybe female colleges, things like that, maybe female predominant, the word's going to come to me, careers, things like that. So even though male and female wasn't a piece of information that was passed into the algorithm to learn from, it picked up on that. And also probably meant that historically there was bias existed in the process already. Okay. And this just accentuated it, right? So there are probably ones now, just from time, there's probably ones that you can probably come across, where AI, hasn't quite worked. I know, obviously spam filter is a good one, where that legitimate mail ends up in your spam folder and you have to go searching for it. There's an example of AI not working. Or I know one in Dublin that people always give out about is, that we have these automated bus trackers, and it'll tell you, oh, your bus is going to arrive in 2 minutes, and 10 minutes later there's still no bus. That's kind of AI getting things wrong. Okay, so there's probably lots of instances that you can come across where AI doesn't quite get it right. And I suppose the thing to remember is that, we very rarely design systems to be harmful. Okay, that sometimes kind of AI failures, they rarely result as a deliberate choice. Okay, as somebody has designed a system to be incorrect. And rather they are usually involuntary harm. So they usually happen because somebody uses a system the way it wasn't designed, because somebody didn't design it very well in the beginning, are just sometimes there's just unintended consequences that no matter how hard we try to mitigate the risks, that something just happens when we deploy a system, that it just doesn't quite work. So it's not possible to fully remove all the harms. So what we want to do is mitigate them as far as possible. Okay. And these are the types of harms. So we can have representational harms, allocative harms, and disparate treatment. Now, I'm not going to go into those in detail now. Okay. Because what I want to talk about is think about that idea as well. How can we, what are the things that we can do as an organization? So where we see an opportunity for AI, where we go, actually, I kind of quite like the idea of using, Copilot or some optimization tool, or, somebody has been on and they want to design a custom chatbot for something, whatever it happens to be. How can we ensure that the AI that we are developing is responsible and trustworthy AI? Okay. So the really nice thing about this is before the EU kind of went about creating the AI Act, they got a high-level expert group just to examine what does trustworthy AI look like. Okay, so when we're saying we want to bring in an act and we want to promote trustworthy AI, what does that actually look like? And they said there are basically kind of 3 pillars to trustworthy AI. It should be lawful, it should be ethical, and it should be robust. Okay, and actually, if you break it down either further, it broke them down, and this is a really nice paper, and it's something that I think it's worthwhile for, if you are interested in kind of developing or incorporating AI systems, I think it's worthwhile somebody in your organization having a look to this document, because essentially there's 7 requirements for trustworthy AI. Okay, and essentially I think it's not a bad checklist just for you to go through and think about, okay, how can we ensure that our implementation of AI is going to be trustworthy and worthwhile for us as an organization. So the first thing is human agency and oversight. So this is the idea: AI systems should support human agency and always allow for human oversight. So both in their design, in their development, but also in their use. That quite often having what we say a human in the loop, so having somebody check the output, is a really, really useful thing to do, and to think about where you're embedding AI into a system, how are you making sure and checking that whatever output is being created, whatever decisions are being made, that they are correct? And do you need a human at that point in the process to go, yeah, this looks right? Okay, so examples there. The idea that we actually, our kind of revenue commissioners here have a text system that looks at, so when people send in a query to our tax office, basically what you write in that query determines what part of the tax organization that your question goes to. And they use a little bit of AI, a little bit of NLP to analyze the text and say, oh, this is about VAT, or oh, this text, this is about somebody's personal tax, or this is about their medical expenses or something. So, and based on what they determine it to be, it gets routed to somebody to then answer the question, right? And they used to have a drop-down list, and that was only accurate 75% of the time. So what they did was they got rid of the drop-down list, and now there's an AI system that analyzes the question that somebody puts in and determines where it goes to, right? But what's nice about this system is that it goes to a person. So if it goes to the wrong person, they can reroute it back to the right person. So let's say a VAT query goes to somebody in PAYE, which is personal tax, they'll know to send it over to the person who answers the VAT question. So that's the human in the loop, right? But by implementing that system, the system now only gets it wrong 2% of the time, as opposed to 25% of the time. So they've garnered huge efficiencies in making sure that the right query goes to the right person. but there's a human in the loop. Okay, so that idea, thinking about how a system is being used or deployed. Okay, technical robustness and safety. So this is the sense that the systems that we are building and deploying our AI systems have to be robust. They have to work. Okay, but also the decisions need to be robust. So what that means is, if I give a person a piece of information, so let's say I write in into a chatbot and I say, I want information. So let's say it's with the revenue. I want information about my tax. If I put that question in 20 times, I should get the same answer out. Okay. The answer shouldn't vary massively. Okay. And that's the idea. So the technical robustness is the system has to stand up, but the actual output itself needs to be robust. So it needs to be consistent. So if I give a set of inputs, I should get a similar output. Okay. Data privacy and governance. So GDPR doesn't go anywhere. Okay. And this is really, really important. Okay. The degree to which AI transparency. So it's really important, if you have a system that uses AI, that you need to tell people that they are, conversing with a piece of AI. So it's, automated decisioning, or, people need to be aware of this and need to be given as part of GDPR actually. If a decision is made by somebody which is based on a machine and has a significant impact on them, they have the option to have that reviewed by a person. Okay. Then diversity, non-discrimination, and fairness. So this is the sense that your system shouldn't discriminate. So particularly if you're making decisions, if your system makes decisions about people, that, depending on, you shouldn't have a different decision based on whether you're male or female, or based on whether you're young or old, or based on the color of your skin. That you have to make sure that decisions that are made by systems, particularly where people are involved, are fair. Need to think about the societal and environmental well-being. And one of the big things we have to think about with large language models, so those text generation models, take a huge amount of energy to consume. So we really need to think about that. And I know it's definitely a hot topic in Ireland with the amount of data centers that we have, and the amount of data centers that we need to run our AI, and the amount of energy that they are consuming. So definitely something that we're going to be looking at, and that will become a topic and a hot topic. And then accountability, really, really important. It is not I suppose, using AI in a tool doesn't give you get out clause to go, oh, the AI said, sorry, that wasn't my decision. Okay. You have to be accountable. So you might get, the AI to create a marketing summary of something, or a brief, or a summarization of a document. You have to be the one. If you're presenting this as a piece of fact or a piece of information, you have to be happy to stand over that it's correct. Okay. Or that you've at least put the processes in place to mitigate where it's not. All right. So just that sense of accountability, you're still accountable for the decisions that are made. Okay. Now, what I'm going to do is I'm just going to spend 2 or 3 minutes. I'm not going to spend a lot of time on the EU Act, just in the sense that it's coming in. So if you are implementing AI systems, you just need to be aware that regulation is coming down the track. It's currently a little bit in flux exactly how it's going to be implemented. I know I was at a meeting with government officials on Friday, and we were just conversing with different people who are working at a European level, and there's lots of decisions still being made exactly how this is going to be implemented. So who's going to be in charge at a local level in terms of, making sure that people are complying with the Act and things like that. There's still a few things to kind of be rolled out and agreed, but it has come into force. So it was endorsed by all member states in 2024. It's a regulatory framework, okay? And AI is classified according to risk. And this is what I want to kind of touch on here. Right, we can talk about the definitions. This is the bit that's important for you to understand, is that the implementation of the AI Act, how AI is classed under the Act is based on the risk that occurs from the outcome. Okay, and depending on the risk associated with a certain AI application will determine the type of action you need to take in terms of kind of adhering to the Act. Okay, so if we look at the different risk levels, so if we look at minimum risk, so you can use permitted without restrictions. So for example, AI enabled video games, spam filters. So for instance, we use Google Mail. Google Mail has a spam filter. Google will have to, so as part of the AI Act, they'll have to go, yeah, you know, this spam filter works. And you can just use it without having to do anything. Okay. So the vast majority of AI systems in the EU currently fall under this category are things like, Google Maps, for instance. There's minimal risk, people kind of using systems like that. Limited risk. So AI systems with specific transparency obligations. So this is where you're using AI systems. So this is some chatbots. So if you're like, the tax authority in Ireland and you're using a chatbot just to point people to information. So somebody says, where can I find information about VAT returns as a small training company? Then, a chatbot might say, oh, you can find information here, and this is the regulation. And so it might give you a nice text summarization and then point you to the right documentation. So something like that is limited risk. In that, you'll have to make people aware that they are talking to an AI or machine. But beyond that, then, and I suppose the idea is that the risk is limited and people still need to know that they're talking to a machine, so it's not a person. So therefore they can, I suppose, mitigate the risk levels themselves, making sure that if they're given documentation, to check the documentation and check the answer and things like that. Unacceptable risk is probably easier than higher risk. So these are systems where you cannot use AI. So things like social scoring systems. So monitoring automated weaponry. So these are areas where AI cannot be used. And here's just a bigger breakdown of them. And then high risk. So these are systems in critical domains that could have a significant impact. For example, critical energy infrastructure, law enforcement, and medicine. So where the impact of being wrong can have a significant impact either on national infrastructure or on impinging on people's human rights. Okay. Then you have to, basically, there are more checks and balances that you're going to have to work through in order to prove that you have tested these systems as much as you can, that any risks that have occurred, that you've mitigated those risks, and that you're constantly monitoring how things are doing. And there's some information in the notes about this. So you can have a look down to that. And here are some of the things that you'll need to do in that high risk category. Okay. So in terms of the Act, that it'll be fully applicable after 24 months. So from May 2024. So we're looking at May 2026. And there are some parts that will be applicable sooner. So you need to think about those. So essentially, you and organizations are going to have to think about just making sure that when they are using AI systems that they are AI Act compliant in the next 2 years. Okay, so now we will go in a really short amount of time, but we have some time for question and answer. I hope that was useful. I know some of you, I know if you've been in EarnAct and you may have heard us talk about this before, but hopefully it was useful for maybe some people who haven't heard us talk. So I'm just going to ask, are there any questions? You can either use the chat or you can just raise your hand and you can unmute. Silence. Either I've answered everything that everybody needs to know, or I've bored you all into submission. Fantastic. I can't see any questions coming there. Like I said, I don't know if you have any questions. So David's asking for use cases specific for SMEs. I suppose in what specific area, David? Do you have any? No problem, Dara. Good to see you.
I see one question. Do you have any information or use cases specific to small medium enterprises?
Yeah, I would say, I mean, if you were to ask me where I see most SMEs using it, is in, I suppose, the generation, the text generation type area. So in those kind of in things like, marketing, particularly in procurement, in writing responses to tenders. I know it's something where we use it quite a lot, and I've seen people use it. So that kind of like summarization, generating first drafts, that generative AI, those tools are really, really useful for that and can do it, if you spend a lot of time like writing text, as I say, either marketing, procurement, responding to tender responses, which can be very labor intensive. That's definitely one area where, people are using it. Then it tends to be a little bit kind of industry specific. So particularly, and depending on kind of what your area of expertise is, like, I've we've worked here with some kind of manufacturing and steel manufacturing type areas that are using it in kind of their manufacturing spaces. The other area that we have a kind of a I've worked with some space people who are developing systems for space, and I know they're using it quite a bit. I don't know if that helps, David, or if you have any specific, like in specific areas.
If
Cool.
there are no
Yeah.
more questions, I don't know, I can.
Yep, and
take-
if anybody has any questions, you can always send them on to me. It's no problem at
Yeah,
all.
sure. And I will link the Q&A QR code. I will need to share my my screen. So, okay. So just a few minutes to remember you to please follow our pages, the website where you can find all the materials, including the updates and activities that we will carry on, and also the recording of the trainings if you want to rewatch it, and also the LinkedIn profile and the Twitter profile. And it's very important for the project to reach a high number of people. And also, I will give you in the chat now. I will put the direct link to the pages and to the Q&A. If you have some question that you will have in these days, and you wanna have some questions, and also to have the feedback, because it's very important for us too. So I will give you here in the chat. I prepared them. Okay. So that's all. You have in the chat all the direct link, and thank you, Ife, for the very nice and super interesting presentation that you made. And
No problem at all. And like that, if anybody does have questions or wants to follow up with me, you're more than welcome to follow up. Because I know it's a massive area, and sometimes people are like, oh, but this little area that we work in, it's really important to us. So do please feel free to follow up. It's no problem at all.
Thank you very much. And to everybody, have a good evening and a good day. Bye.
Thanks, guys. Good to see you.
Thank you, Ifa.
You're so welcome. Good to see you again.
Yeah.
Hope all is well up in Buncrana.
Everyone is good here around here, but now we are in Letterkenny. But yeah,
Okay.
yeah,
Fantastic.
the office is in Letterkenny. But yeah,
Okay. So you only get to visit Buncrana for nice events in the
just for
in the new hub
events,
there.
only
Yeah.
for the crack, only for the crack.
Oh, well, it's good. It's a good place for the crack, I'd say.
Definitely, definitely.
Fantastic. Brilliant. Well,
Thank
it's
you.
great
Thank
to
so
see
much,
you.
Aoife.
Thank you, Aoife, and thank you, everybody.
Thank
Thanks,
you.
Jose. Thanks a
Bye.
million.
Bye.
Chat to you
Bye-bye.
later. Bye.
Bye.